for liftoff.
Ready?
We're ready.
Cool.
So, welcome everybody to Kent Armstrong Returns, the sequel. Kent was with us, I think it was in 21 or 22, and it was a fabulous chat. We talked about more about Kent than we did about anything else, which was great to get to know Kent and his history and his background and that kind of thing. I wanted to have Kent back. I ran into him up at in October at the
Woodstock show.
Woodstock show, right? And and we had talked about the Luth group and having Kent back on. And I said, sure, we'd love to have you back on again. What do you want to talk about? He said, I want to talk about guitar electronics. And the guitar electronics is something that obviously he knows quite a lot about, and I know enough about it to keep myself from burning myself with a soldering iron, which is probably a good match. I've muddled through with electronic stuff for most of my career, and for the most part, managed to get to the end of a usually very frustrating and profanity-filled hour or two to get a guitar to come out of an amp, which to me is still a certain amount of, there's still a certain amount of magic involved that somebody can plug this little cable in and somehow all of these notes manage to squeeze their way through this long cable and come out of an amplifier sounding like a guitar. And it's something that I've as a luthier, I've been able to, sort out whatever I've needed to sort it out, but it's still one of those areas that I find to be kind of just as mysterious as it is frustrating half the time, because when something isn't going right, and often it doesn't, to me it feels like somebody's turned off the lights and said, ready, shoot, aim. And that's the way I've always done it. And I know there are members of our group that are like Jerry Hayes, for one example, is that has this stuff well figured out. But I thought it would be a great conversation to have Kent on and have him kind of give us an electronics. I don't know if it's an electronics 101 or an electronics overview of all that stuff. So welcome, Kent. Welcome back.
Glad to be back. Glad to help you guys out. I quite enjoy this, actually. So let's start with something Doug had said. Soldering, not burning yourself, good thing. But guys, don't use anything smaller than a 30-watt soldering iron. We have two soldering irons here in the office. One's a 30-watt and one's a 60-watt. The 60-watt is for doing tough jobs like soldering to stainless steel. We have special solder for that. But there's 25 watts out there and 15 watts. You want to apply heat as quickly as possible and get the soldering done quicker. I've had people call me up and they've literally burnt the pots out because they had such a small soldering iron trying to solder a ground onto the pot, and they've burnt the pot out. So you want it to be really quick. So definitely use a 30 and have a backup of a 45 or even a 60, but nothing smaller than a 30. It's really tough to work with anything smaller. So definitely go that way.
While you're talking about soldering irons, and this is just my ignorance, and I don't know if there's a way. Yeah, but I got one of these old suckers right here.
Yep, I've got one too. I've got one right here too.
So when I'm setting this, I normally just turn it on and turn the knob all the way up. Is that wrong? Is there something I should be doing more appropriately with it, or do I just?
Well, Doug, we haven't used that one I just showed you, the big one. We haven't used that thing in probably 15 years. It's
Really?
got more done. Oh yeah. The good thing about using a soldering iron like I just showed you, like this. Good thing about using a soldering iron like this is you know exactly what it is. You don't have to worry about temperature. You don't have to worry about anything else. You know it's a 60 watt and it does the job.
Oh, okay.
That's what that, because those other ones that you can set them up and down. And you can. I have no idea what temperature is good. Not a clue what a good temperature is. I just know that a 30 watt works and a 60 watt works. And
Okay.
when you just don't. Those things are expensive, and you've got to know because it's a Radio Shack, and like I say, it's got to be over 20 years old, and like I say, we haven't used it in 15 years.
Right.
Just don't mess with it. Just stick with what is simple, easy, and the whole of this talk will be simple and easy.
Right.
There's no need to get complicated, and that thing is, I mean, it's just too complicated. I know the 30 watt does the job. It's the same with solder. Get Use the self fluxing solders. Don't use and jeepers creepers. Stay away from that Roja stuff. Roja, whatever it is. Just get the old fashioned 60/40 solder. And I also have some very special solder. It's called aluminum solder.
Hmm.
And this solder will solder stainless steel and aluminum because it's got 2% silver in it, and it's the reverse of normal solder. Solder is 60/40. This stuff is like 48/60 the other direction. It's got more tin and it spits a lot more, but it solders right to stainless steel and solders aluminum. I mean, you could give me an aluminum canoe with a hole in it and I can just solder the hole, flatten out the plate and just solder the hole with a 30-watt soldering iron.
Hmm.
You clean up the aluminum and I've repaired aluminum canoes with it. Works really good. So anyway, let's get back on to something else after that. Potentiometers, guys. There's so many stories and myths about potentiometers. To be perfectly honest, you cannot fail by just using a 500K pot for volume and tone if you want. Just stick with it.
Now, when you say you can't lose by using a 500K pot, a lot of us um, in this field have been kind of conditioned to think about, Strat's always using 250K and Les Paul's always using 500.
Okay, before we go any further, I get what
Okay.
you're saying. And Telecasters, they've used 1 megs.
Right.
Okay, the problem with using a 1 meg is, for first, a 1 meg you'll understand is the better way to go, but it's not, because with a 1 meg pot, all the volume tends to be between 1 and 3, and then from 3 to 10, nothing happens. It's just, I mean, in a moment you'll understand why it's a good thing, but it's a bad thing. Um, and this is to do with pots. Amplifiers have what are called front end loading. They have a front end resistance, which means when you plug it in, there's resistance. Now, there's a thing called parallel resistance. And when you're using a potentiometer, what you're doing is you're putting, let's take 500K potentiometer. You're putting a 500K resistor in the way of ground. Now, if you have a 500K front end loading, we're going to use that as a simple number. So you got two resistors that look like this. Their legs are connected, except in our case, we've separated one legs. This is the amplifier. This is going to ground. So in that case, if you had a front end loading of 500K and a 500K volume pot, when you turn the volume pot full on, you're only getting 50% of the power going to the amplifier. Because in a 500K resistor and a 500K resistor, when you put them together, you put the electricity to pick up through here, it splits itself. It splits itself into half. Half of it'll go to ground, and half of it'll go to the amplifier. Most amplifiers have like anywhere from a 20K to 100K front end loading, which means in the case of a 500K pot, you're still getting some leakage to ground. And the only way to actually assure that every ounce of electricity of your electrical system, meaning pickup or piezo, whatever it is, the only way to assure that it's getting there is to either put in a bypass switch or don't put any controls in. If you took the pickup and wired it straight to a jack socket, no volume, tone doesn't matter. Tone's a different thing. We'll get to tone later. You'll assure that 100% of all the tone and volume is going straight to the amplifier.
So, just to back up a second for myself, my edification, and people who are as uninitiated as I am, when you're dealing with a potentiometer, you're dealing with a variable resistor.
Mm-hmm.
So
Mm-hmm.
on one end of the pot is 0, at the other end of the pot is whatever the rating of the pot is, the ceiling,
Correct. Mm-hmm.
500K or
Mm-hmm.
250K or 1 meg, whatever the rating of the pot is. So when you're, and let's restrict the question to, like, say, a 500K pot. If I've got a 500K pot in my circuit, you're telling me that 50% of my signal is being fed to ground?
It could be depending upon whatever the front end loading of the amplifier is.
Okay,
There's still some leakage to ground.
okay,
Even if let's assume they've got a for argument's sake, say 50K front end loading compared to a 500K pot. You're still losing 1/10 of your power to ground when you think the power is full on.
but that's being determined by the amplifier then.
I'm afraid it is. Absolutely. Yeah, that's it. And that's why in the case of a 250K pot, in most cases, it's way too small. It's just too small. You got too much leakage. Now, 1 meg is better, but the 1 meg pot behaves so badly in the instrument, it's not worthy of using it. So, like I say, what you can do is with a simple wiring trick by using a push-pull pot, you can take the volume pot out of the circuit. And people have actually done this. And when they got the volume full on and they pull up on that pot, on the push-pull pot, they say, all of a sudden it's like my guitar got supercharged
Hmm.
because all that extra energy has now gone to the amplifier. So if you're ever concerned about whether you're getting the full power to the amp, either don't put in a volume tone system or put in a push pull pot so you can literally bypass the volume, take it out of the circuit.
Okay.
I mean, it's like I say, it's pretty important in certain aspects. But like I said, a 250K pot is just in the case of a 50K front end loading and a 250K pot, you could be losing as much as 20% of your volume,
Hmm.
not getting to the amplifier, leaking to ground. Like I say, you're putting a resistor in the way of ground. That's all you're doing, a variable resistor.
So just to put a finer point on it for my head's sake,
Mm-hmm.
you're saying that the front end loading is taking place at the amplifier,
Mm-hmm.
but the uh, the use of different variations of pots, a 250 to a 500 to a 1 meg or what have you,
Mm-hmm.
um, is allowing a certain amount of your signal to be lost to ground that's controllable at the guitar to compensate for this front end loading that's happening at an amp?
Well, it's only controllable if you use a system that bypasses the volume.
Right.
That's the only way you're going to get it all back. Like I say, if you want to know for sure, 100%, that all your power is going to the amplifier, none leaking to ground, you've got to put in one of two systems. One, no volume. I mean, you can still put a tone in, but no volume. The volume is the problem. You need to either have a little switch. You could put any kind of little tiny little switch
But you're gonna
in.
have a hard time talking guitar players out of their volume control.
Oh yeah. Well, and in fact, it's funny you should say it, Doug, because I do talk to people about this, and I say to them that the volume and tone control is nothing more than an extension of the amplifier up to the guitar. I mean, most in the old days they'd go to the amplifier and turn the volume up, turn the volume down.
Right.
The good thing about an amplifier is the passive system we generally use in guitars is strictly a passive system. There's no boosting. Whereas on amplifiers, you can go plus or minus, 10 each direction on some amplifiers, on the tone controls.
Right. Okay.
But you can't do that on the guitar. It's strictly a passive system. So, if you stick with 500K, you're in a pretty good ballpark. So,
Doug,
250 is just too small.
Doug, do you mind if I ask a question? Is it okay to
Oh,
interrupt?
by all means, yeah. I'm the worst person to lead Kent through this conversation because I'll ask the dumb question. So,
Well, I'm going to ask a dumb question too.
good.
Kent, hi.
By the
Just
way, before you start, Jerry Hayes is a member of the Luth Group who has probably written one of the most impressive books on guitar electronics ever written. So if you haven't seen that,
No, I'll look that up.
this is Jerry Hayes.
well, that prefaces my dumb question really nicely. Thanks, guys. Um, Ken, I just wanted to ask. I've long said that once the signal is outside the output jack, it becomes somebody else's problem. So I know very little about amps or front end loading, or what the usual values are. But I do know from putting bypasses and blower switches and whatnot into guitars that there is certainly a difference, but it doesn't tend to be a day and night difference. I'd have said it's you eke some more out of it, but from what you were saying, it seems like you'd be thinking about a bigger effect. And I just wanted to ask, was I doing something wrong, or is my amp particularly lowly loaded, or what?
Exactly. That's exactly what it is. It's that your amp does not have a great front end resistance. It might have only 1K. And in that case, compared to 500K, you're losing maybe 1%. So that's why you probably wouldn't hear anything. But again, it's all down to amps. It's just what they are. They're not all the same. They're not all the same whatevers. So
Do you have a feeling for what is a typical resistance for an amp?
they're usually around. Uh, I don't, I've never measured a lot of amps, but around 20K. You got
Okay.
most people have told me it's a 20K resistance, and so that way you're losing a couple percent.
Yeah.
It's nothing bad, but if you then use a 250K pot, you've doubled the problem.
So that begs a question for
Thank
me
you.
as you're servicing a customer and you're trying to listen to a customer's complaints about a given guitar, if they're and I've heard this a gazillion times from customers who will point to a given guitar and say, for some reason, this guitar of mine just doesn't seem to have, the whatever descriptive factor coming out of the amp. They would say the oomph, the volume, the guts or whatever, as my other guitars. And if you're looking at a guitar that has 250K pots in it, would a suggestion then be to the customer to change the pots out to a higher value of pot?
It couldn't hurt, but a prime example of this fact, you have to look at other factors too, like how well was the guitar set up? I had a brand new Rickenbacker come in here just a couple weeks ago, and the guy said, it just doesn't sound like a Rickenbacker. It's just not up there. Well, the pickups were so far away from the strings that I could put my fingers in between the strings and the pickups.
Mm-hmm.
So all I did was set up the guitar correctly. And when he got it home, he called me up and says, "Oh my God, it sounds just like a Rickenbacker now. It's great. It's got everything you need." So there are other factors too. You can't just say it's the pots. Yeah, you've got to also include any other factors that might be in. It could be a guitar with bad magnets. You don't know. So I'm just trying to, because we're talking about pots and controls.
Mm-hmm.
That's what I was trying to get across. That's a minor symptom of what it is.
Okay.
So
So circling back around to pots, you made an allusion to the fact that in theory then 1 meg would be better than 500, but there are downsides to using that.
right, exactly, yeah. Mm-hmm. Yeah,
That's what that it doesn't have the sweep that
it just doesn't have the sweep. It all happens in the first three numbers, and then you can turn the rest of the knob up till the cows come home, and it doesn't change anything because that resistance happens in that sweet spot of up to like 300K. So that's the problem. That's the problem with using that. The next thing to discuss is log and linear pots. I don't know if you guys ever get that as a problem.
log and linear. Tell me what that means.
A logarithmic, if you actually saw the pot on its graph, it's a big C curve. huge big C curve. So it's the way it operates. Whereas a linear pot, if you look at the graph, it's a straight line, whether it's up or down, whatever, but it's a straight line. I personally, to my ears, I prefer linear. But
So is
most
that
of what
what people refer to as audio taper pots and linear?
audio taper is the C taper. Yes,
Okay.
that's logarithmic. It's actually logarithmic. It is not linear,
All
and
right.
it's usually denoted by A and B.
Okay.
And when you look at the nomenclature written on it, it usually says A or B.
And which is which?
Um, uh, A is analog, and B is C taper or logarithmic.
Okay.
Right. But I mean, it again, to me, it's your ear that tells you what you like to hear, how it
Okay.
goes up. I prefer linear on my guitars.
What is it that you prefer about it? What?
It seems to be smoother. It seems to come on at a nice smooth rate. It doesn't just jump right in there and it's on.
Okay.
And then nothing happens for the last few numbers. I just prefer it. To my ear, linear is just the better. I mean, everybody has their own, but I just wanted to bring in the fact that you got logarithmic and audio taper.
Okay. All right. I've always been just conditioned to the fact that since it's, an audio signal, we would be using audio taper pots.
No, the audio refers to the way it actually maneuvers.
Okay. All right.
That's what that does. Okay,
Yeah.
let's move on to the tone pot. Tone pots are not quite so critical in respect of their values. I use 250s, but of course you can't go wrong with a 500, as I said. And a
Now
tone
you'll
pot,
use a 250K tone pot when you're using a 500K volume pot?
yeah, mm-hmm,
Okay.
yeah, yeah, because they're two. First of all, a tone control is something that if you were playing a guitar and I could get to your electronics, I could go in there with a pair of wire cutters and cut the tone control right out of the circuit. It's a leech. A tone control is nothing more than a leech. It sucks frequencies away and throws them to ground. That's all it does. Because
Okay.
this is a passive system. And there's the next thing is the capacitor. People go on about these orange drop capacitors and these great old oil-filled capacitors, and I mean, if you're building a hi-fi system, it's probably relevant. But what we're using it for, I use a nickel capacitor, a cheap 64 volt nickel capacitor, because it's doing a leaching job, because it's sucking the frequency and throwing it to ground. It doesn't have to be a high quality. I mean,
In other words, it's reductive. It's removing rather than adding.
It's only in an active system can you enhance.
Right. Okay.
Or boost, if you want to call it a boost. So the capacitor does not need to be of high quality, high expense. A nickel capacitor will do the job just as well as a orange drop capacitor.
Well,
I mean,
how do you then swim against those currents of what the consumer, as the guitar owner, is expecting?
I stock orange drop capacitors.
Okay. Fair enough.
What else can I do?
Yeah.
The customer is king. If the customer wants that, I do try to convince them that, here, I'll sell you one for a dime, or I'll sell you this one for $5. You choose. They do the exact same job.
Right.
It's crazy. Now let's talk about value. Now, remembering that a capacitor sucks away frequency and throws it to the ground.
Right.
Frequencies are also the energy of the pickup too. If you put too big a capacitor, a guy called me up one day and he said, well, it was on a bass guitar, and he put in a 0.1 capacitor. 0.1. And he said, when I turn the tone control up, all my volume it's gone. And I said, well, you say the only thing you've changed, you put a new capacitor. I said, read me the numbers. written right on the capacitor. It said 10-2. It was 102. And the last number 2 tells you take the decimal point over 2 places. And
Right.
it told me he was dealing with a 0.1. He was throwing 99% of his frequencies to ground. It was 10 times too big.
So when you're looking at capacitor values as it relates to your tone control, how do you decide what? I mean, is it the pot that tells you what size? Because I was always conditioned again that Strats use .02 and Les Pauls use .04, whatever it is, .04.
No. Les Pauls use 0.022 and Strats use 0.047.
Right, vice versa. Right.
Yeah, vice versa, whatever. Whatever. But no, 0.02. But you have to be careful because a 0.047 is sucking. If you look at the sound spectrum, say the bass end is 0 and the top end is 100. A 0.022 might suck away everything from, for argument's sake, 100 to 90. Then a 0.033 might suck away everything from 100 to 80. A 0.047 will probably suck away everything from 100 to 70. But as you get bigger and bigger and bigger, you're also throwing away your electricity because the signal is part of the energy that's coming out. So people do complain when they're using 047 that it's their volume drops dramatically, especially on a pickup that is of higher frequencies like Telecasters and Stratocasters. They're very bright and toppy, so most of their production is high frequencies. And of course, they do use an 047 so they can super mellow out a Stratocaster. Well, the problem with that is you've also thrown away probably 30% of your energy.
So, so why? I'm not sure if I know how to ask the question. Why then have we been told all our lives that Strats use one capacitor and or single coils use, and I say Strats and Les Pauls because I'm referring to either single coil or dual.
Mm-hmm.
So why are we conditioned to think that if it's a single coil, you always use one type of capacitor, and if it's a dual coil or a humbucker, you always use a different kind of capacitor?
Real simple. It's because it was done first. That's the way it was done in the olden days.
Okay.
I mean, the problem with guitar players are they're pretty staid in their ways. In fact, as I said, I believe in my first meeting with you guys, if you're not building in the electric guitar industry, solid bodies, if you're not building a Les Paul, a Telecaster, a Strat, you're not in the guitar industry because we're still selling Model T Fords.
Right.
I mean, that's the way it goes. So basically, because this is the way it was done in day one, everybody wants it still done day two. They're not willing to change. I mean, most guys who call up saying when they got a .022 in their system and they said, well, shall I put a .047? I said, why don't you try a .033 first and see if that helps you? And in most cases, it pretty much cures the situation. It's just too big. You don't want to throw it away. You just don't want to get rid of it.
So the smaller the size of the capacitor, the more highs you're allowing to pass through the pot to the amplifier.
No, just the other way around.
Okay.
The other way around. Right. So if you put if you put a .01 in, you'll throw away from 100 to 95. You put a 022 in, you're going to throw all the frequency away from 100 to 90.
That's when you roll on the pot.
Right, when you roll on the pot, absolutely. Yeah.
Now, is there depending on the size of the capacitor you're using, is there an attenuation for when the pot's up full, or does it matter?
Well, again, it's a matter of the resistivity is permitting things to flow. Does that make sense?
Yeah, I've always thought of audio signals kind of like water in the sense that there isn't a direction. It just goes wherever the wires go in both the.
Well, the good thing about a capacitor is by the means of it's constructed, if you try to measure a capacitor with resistivity, it has none, because it's two giant aluminum pieces of foil with an insulator in between them, and each one has got a soldered leg to each sheet of aluminum. It is then rolled up, so there's no way that the two sheets of aluminum are touching. And what happens is electricity builds up and it arcs across the film layer in between the two pieces of aluminum. And that's how a capacitor works. So it's waiting for frequencies to arc across. So depending upon what the value of the capacitor is, it depends upon how big the aluminum is or the way it lets electricity flow across it. But it doesn't flow across like anything else. It's quite unique in its way. It's not a diode. It's strictly, like I say, the two sheets of aluminum with insulation in between them and then rolled up. So it's like it's hard to explain, but it's dependent upon how quickly something acts or doesn't act. The tone control is not nearly so critical in its value of either 250 or 500. Again, it just depends on how quickly it acts.
Okay, so that the size of the pot has more to do with how much signal you're gonna and how quickly a signal is gonna pass through your capacitor. The size
Precisely.
of the capacitor is controlling how much of that frequency you're gonna lose to ground as you turn up the pot.
Right.
So as the guy who's sitting at the bench, trying to keep myself from poking myself in the eye with my soldering iron, because I'll have the soldering iron in my hand and I'll go and move my glasses like that, holding the soldering iron too close to my head. So how do I determine with any given guitar what capacitor is better for a particular guitar? What's helping me make that decision, or do I just come up with a rule of thumb that I'm always going to do what?
Well, no, I would trust your ear, because everybody's ears are different. So I would trust your ear. If you're feeling it's not giving you enough cut, if you're not getting enough, leftover bass response, if it's not big enough, try an 033 or an 047.
Okay.
It's got to be your ear. See, most people rely upon electronics for telling them what's right. Well, actually, it's the human ear that tells you what's right and what's wrong. It really is. I mean, when you build a classical guitar, if it doesn't sound right, it means, well, I didn't get the bracing right, or something, or the guitar's dead. So let your ear really be, and of course, the customer will come back to you too, and the customer will say, "Well, I'd like a little more cut or whatever." The customer is king.
Right.
It's really important. Let's move on to something else.
Okay.
Let's move on to wire. When you are actually wiring up an instrument, this is really important. You need to keep hot live wires as shielded as possible. I'm just looking to see if I've got a piece of wire here somewhere, because here's a piece of wire. Now this is single core screen cable.
I can't see what you're holding.
No, I'll show you in a second. Just let me get there. See that?
Yeah.
Now, that's about as much exposed live wire as you want to have live exposed. And here's my finger next to it. Okay, so you can see it's not very much.
Right.
Because I get people who call up and they say, "Well, I've got all kinds of noises." And I'm talking about luthiers. And what they've done is they've taken single strand wire, like this single strand wire.
Yeah.
And they've taken like red and green, and they've run it all the way from the controls down to the jack socket. So they've got something like 8 or 9 inches of hot wire picking up all kinds of signals because of the two types of signals. You got to keep your wiring, your hot wiring, as little as possible exposed. See the white?
Mm-hmm.
You want to keep that as minuscule as possible, because you're gonna pick up all kinds of RF noise. Oh, forget the hum. It's the RF noise, from fluorescent lights, dimmers, amplifiers. So you got to keep your wire short.
Let me ask a question about that, because when you pop open any given cavity from almost any manufacturer of an electric guitar, whether it's a Strat and you flip over the plate or a Les Paul, there's only certain wire in the cavity that's shielded. And it seems to be shielded from the pot to the first switch, or to the first pot, from the pickup to the first pot, and then from the output of the pot to the jack. Everything else seems to be, in half of the guitars I've ever seen, has single strand wire, like going from the pot to the tone control and all of that stuff. Are those areas where you're going to pick up noise, or?
Yes, they will do if you're not. You remember Gibsons used to have a little metal box. Everything was in a metal box.
Yes.
Okay, well that's your Faraday cage. That is preventing the signals because the box is connected to ground. You don't have to worry about it in the box.
Mm.
Okay, you have to worry about it from the pickup to the box, to the box, to the jack socket.
But
Okay, the box.
nobody makes guitars like that anymore.
No, well, they put shielding in, and
Yeah.
guys, unless you're an expert with that shielding paint, don't use that stuff. That can actually create more noise than you're getting rid of.
How so?
Because it's little carbon particles, and if every single carbon particle is not touching its neighbor, and then its neighbor, and then its neighbor, and creating the chain out of the instrument. I've known luthiers to have put as much as 10 coats of that stuff on to get 100% shielding without generating. So one little tiny carbon particle that is not going to ground is going to generate noise, a little bit of noise. But if you got tens of thousands of those little particles not touching the ground, you're going to have a huge amount. I had one guy call up. He said his guitar was screaming. He'd put one coat of this paint in there, and it wasn't enough. It just plain didn't work. So stay away from that.
So what do you recommend? The foil?
You stick to foil. Yeah. If you're going to do it, stick to foil. Yeah, stick to foil. I mean, and of course, like on Stratocasters, the back of the pick guard is shielded and screened, but it doesn't do anything for the front of the pickup, which has got a plastic cover on it, which picks up all kinds of noise.
Right.
So it depends upon. I mean, to be perfectly honest, Stratocasters are really noisy boogers. I mean, they really just are noisy, phenomenally noisy, because there's not really. And of course, when I first started out in 1970 at my dad's repair shop, everybody was taking their humbucker covers off. I had the biggest drawer full of. I mean, I had hundreds and hundreds. They were ripping them off right, left, center, and there was a good reason. I mean, it was a good reason, because basically, when you take the cover off, your screws are now too high. So you lower your screws, you raise up the whole pickup, and the whole pickup became much more powerful because the slug pull pieces were so far from the strings, they weren't really generating much. They were just sort of there. The magnetic field was very weak. So. But in that case, though, they gained power, but they lost the Faraday cage. So the humbuckers were picking up RF noise. So it's a trade-off. And that's why I actually manufacture 12 pole pickups. I have all 12 poles coming through the cover. So you get the power and you get the Faraday effect.
I think your pickups are the first ones I ever saw have 12 poles, if I'm not mistaken. I think you were the first guy to do that, right?
Yeah, but the old Hofners, they had exposed slug pieces. There were a lot of pickups out there that had, like 6 pole pieces and 6 slug pieces coming through. So that's pretty good. And the another thing about the wiring, I had a very famous customer of mine, very big in the business. He called me up one day. He said, "Kent, I've got this dreadful buzzing sound. Dreadful. Oh, I don't know what to do about it. Every time I touch something metal, it buzzes." He said, Can anybody guess what was wrong?
Oh, you talking about a grounding issue, or did he have the signals reversed?
You basically got it. He had his jack socket wired backwards.
Yeah.
So now the ground was the live and the live was the ground. So every time he touched something metal, it was his body was picking up the frequencies and transmitting them into the live system. He'd spent 2 days trying to figure out what was wrong. He calls me up and I said, "Hey, why are your jack socket backwards?"
Yeah, that's one that the first time you learn that, I think that sticks with you for the rest of your career.
Well, going to the next part of a jack, it is a good the switchcraft jack really is about just the best jack out there. So
Hmm.
if you're going to use jacks, use the switchcraft ones. Don't use cheap ones. It's worth the extra money, but switchcraft is the best.
Right.
Now, I don't know if any of you guys have ever thought about building electromagnetic and piezo or piezo, whatever you want to call it, technologies. Now, you can't wire them together and come out of a mono jack.
Right.
It just doesn't work. You've got to buffer. Something has to be buffered. The impedance resistance of the two are so far apart. You can't. But I've taught a lot of people how to. You have to use a stereo jack and probably a stereo output and stereo wires or two jacks. But the cool thing is by using a switchcraft stereo jack, depending upon what you want to make the primary electrification of the instrument, i.e., electromagnetic or piezo, um, by wiring it up correctly, you can, if you make the tip of the plug you put in, if you
Yeah.
make the tip, make it hot, you can make it hot, say, for the electromagnetic one. And that way you can actually still use a mono cord. And if you use the mono cord, it goes into the guitar, into the amplifier, and you're using the electromagnetic. Or if the customer prefers to use the piezo more than electromagnetic, again, make it the tip hot. That helps. So you can still have both three systems basically.
So you're saying if somebody's got a dual system in their guitar,
Uh-huh.
and I mean, I go back, shit, probably 25, almost 30 years ago, having to deal with John Abercrombie had a Brian Moore that had both electromagnetic and had a piezo in it, and it was the biggest headache I ever. Um, and I can't tell you how many times I had my hand at rewiring that guitar, but ultimately, obviously, we went for because he was looking for, at something where he could just plug one plug in and stick in an amp and have both come out, and it was not going to happen. We wound up having to go with a stereo solution.
Mm-hmm.
So you're saying that if somebody's got a guitar with both, you can give them the option of um, just plugging in a mono cable and restricting the primary use of a mono out
Mm-hmm. Mm-hmm. Mm-hmm.
to
Absolutely. Yeah. Mm-hmm.
one or the other,
Mm-hmm.
and no harm, no foul. Then
Yeah.
the other one's
No
just
problem at
being
all.
grounded in that
Nope.
one.
Doesn't hurt either one of them. No.
And
You
then
Could
if
I?
just
they want to go with a dual signal, they can plug in a stereo cable and separate it at the amplifier.
or in a couple of guitar friends of mine have actually put in two jack sockets.
Right. Okay.
That way they use two mono cables going out to the amplifier because most amplifiers have twin inputs
Hmm.
and they're able to control them independently because the amplifier then buffers the signal.
Yeah.
Do you mind if I interrupt again? Apologies.
Oh no, by all means.
Kent, is it okay to add a little nuance to that last point?
Sure,
Um,
absolutely, please do.
a number of the dual systems now with piezo and with magnetic, they will have an active preamp on board for the piezo end, and the stereo jack is often doing switching duty there. So it's actually acting as a power switch for the
Right, yes, yeah. But
so
again, because you've got an active system on board, you're quite right. They're using the other of the stereo to turn the battery on and off because the moment you unplug it, it breaks the ground of the battery. Doesn't break the live, it just breaks the ground of the battery. But yes, but okay, you have to wire. What happens is the electromagnetic is wired into the electrical system, and it is buffering.
true.
It has to. It brings it because quite often what it does is it just sends it through two little capacitors. And because as I said, because you can't measure a capacitor because there's no. So what comes out the other end is of equal resistance between the electromagnetic and the piezo.
Mhm.
So yes, that's quite. But the onboard electronics is doing the buffering.
Yeah, absolutely. The dual input is, or rather, the dual output is still possible if you use a switched jack for
Oh,
the
sure.
power.
Yeah. Yes, of course you can. Yes,
Cool.
yes, of course you can.
Thank you.
Yeah. Any other questions?
By all means, if anybody's got any questions while we're having this conversation, they should jump in and, you know.
Okay. The last little topic I want to talk about.
I think Trevor Healy, did you want to jump in there?
Yeah, can you hear me okay?
Yeah, I can hear you now.
Okay. I have experimented a lot with capacitor value, like you guys were talking about, and I'm curious if you ever made any analysis of the voltage of the capacitor, because I try and keep the voltage
You're
on the low end.
coming through a little muted. Sorry.
Yeah, you're a little muted. No, he's talking about voltages.
Let me start over.
No, I think I got the gist of what he wanted to know. He wanted to know about the voltage of the capacitor, because capacitors have a voltage rating.
Yeah.
Well, because we were dealing in millivolts, which is thousandths of a volt, you could use a 1 volt capacitor if you could find them, but they tend to be 64 volts, and that's well covered. Now, basically, if you put 100 volts through a 64 volt capacitor, you'll burn it out. You'll literally fry it. So because we're dealing in thousandths of a volt, I mean, the hottest pickup I ever manufactured put out 1 volt.
Mhm.
It peaked 1 volt. So a 64 volt, and you don't tend to find anything smaller than 64 volt. They're cheap, little tiny, little round. It does the job beautifully.
Yeah, I think for the most part, like the orange drops and stuff are around 200 for the
Right.
that are sold for guitars. But then, people accidentally walk in with 600-volt ones that are meant for amplifiers and stuff.
Exactly. I mean, you can use them. There's no problem.
Right.
It's overkill. It's super overkill. And because this is pretty much what was around, you got to remember when guitars were invented and designed back in the 50s mainly. This is pretty much the norm, was buying radio, TV capacitors and resistors and things. And it's sort of the carryover from the old days. Nothing wants to change. It wants to be the same. It's just nasty. Hey, listen, next subject before we have to go.
Before we do that, Rhett Harris, do you want to unmute and ask your question? Because I'll wind up butchering it.
Yeah, certainly. My question would be, can you measure with a multimeter if a pot is either audio or logarithm? Like with a multimeter?
Yeah, not easily. It really is not easy. What you do is you take one end. Remember, there's 3 contacts on the pot. Take one end, put your meter on that one, and put the. Now you need to use a digital meter. Don't use a swinging needle. Don't.
Yes, of course.
Got to be digital. Put one leg here and one on the center sweep. This is called the sweeper, and just move it around. Just move it along and watch the numbers go up, and just take note. And at the halfway point, it should be half the. Now, wow, something I sort of missed, and I should do. Don't always assume the value of the pot is correct.
Okay.
Because pots have a plus or minus tolerance, unless you're buying military spec, of plus or minus 20%. And when you're talking 500K, it could be as low as 400K or as high as 600K. Take your meter and measure across input 1 and input 2. Now you're measuring the carbon track. I actually go and measure all my pots, and with a felt tip pen, I mark right on them. The lowest value ones I use for tone controls, and the highest ones I use for volume controls.
Oh, it's
Interesting.
Yeah, it works out better. You really want, a 400K. That's a lot of K difference between a 500K. So you got to make that. So you can actually watch it increasing on the meter. You'll see either a nice. I mean, the thing to do is get yourself a logarithmic one and get yourself a linear one and actually watch them as they slowly go up and down. Best way to do it.
Thank you so much.
Well, you're more than welcome. The next thing I want to do is just, even if we spend 5-10 minutes, is fault finding.
Say that again.
fault problems.
Oh yeah, you're doing
problems.
about
Yeah,
troubleshooting the guitar.
troubleshooting. Yeah, troubleshooting or whatever. Don't always assume it's the pickup is the problem. And almost everybody who calls me up says, well, the pickup's the problem. Well, it's not. Quite often you can have a bad pot. You could have overheated the pot and the little sweep is now floating or barely touching, and you can actually warp the track.
Okay.
So one guy called up and he said, well, my pickup is skipping. It comes on and off. I said, what are you talking about? He says, when I move the volume control, it's turning on and off. I said, oh, you've burnt out your pot. And sure enough, when he sent me a picture of it, there were so many different places that he'd been trying to solder onto it. He'd burned out the pot.
So before we get further into diagnosing a problem, let me ask you a question that is always an assumption that I had, or was always the answer to a question that I was the only answer I ever had. So when I was talking to a customer, whenever I'm talking to a customer about a pickup or what they perceive as having a pickup problem, because of course every guitar owner will say there's something wrong with my pickups. Because if they plug it into an amplifier and nothing comes out, they assume the pickups are bad. And of course, as you think about it, if both pickups don't work, it's probably not a pickup problem.
Right, absolutely.
The way I've always described it to customers, and now that you're here, I can find out if I've been BSing my way through this for the last 40 years, is that I've always been of the understanding that there's only two ways a pickup can die. Either the coil is going to break and therefore it will have little or no output, or the magnet can die and it's just dead. Is that?
You've nailed it. You've nailed it. There is one slight other which goes along with the coil breaking. Quite often, a copper wire can actually fracture.
Mm-hmm.
In other words, imagine this is a very, very thin piece of copper wire, and it's just fractured inside its coating. It's just fractured. It's got a crack in it right across it. What it does then is, does that sound anything familiar like we've talked about today? A capacitor?
Yeah, okay.
So you've got two pieces of copper wire with a gap in between them. Well, I get people calling and said, my pickup's gone really trebly. It's got not a lot of volume, but it's gone really trebly. And it's one of two things. One, he's either got a cold solder joint, which means electricity, only the high frequencies is getting across, or in the case of the crack in the wire, only the high frequencies are able to jump across the capacitor gap.
Mm-hmm.
So that's in essence is a broken coil. But you're quite right. That is it. I had one customer call up, and he said, on all three of my Strat pickups, I think I might have mentioned this last time. All three of my Strat pickups, the B string is deader than a doornail. I mean, deader. What's wrong with my pickups?
Mm.
And I said, you ready for this? Change your string. Just change the one string. Sure enough, he called me back like 10 minutes later. Yes, he had a dead string. There's no way three pickups could simultaneously have the exact same problem.
I get you.
Again. So most people, I mean, if you're having a problem, the first thing to do is wire the pickup straight to a jack socket and plug it in. And if everything's normal, that tells you have something from the controls to the jack is your problem. Very simple.
Okay.
I mean, and the number of times that people come back to me and said, they find out. And one customer called up. He said, as I'm gigging with this thing and I move around, my guitar cuts in, cuts out, cuts in, cuts out. I said, okay, well, take it, plug it into your amplifier right now, start playing it, hold a chord, and wiggle your jack going into the guitar. Sure enough, his jack plug was all bent out of shape.
Mm-hmm.
So as he moved around, it was making contact, not making contact. And basically, he had a cheap, crap jack. The terminals had all moved out. They weren't made of a good spring steel.
Mm-hmm.
So it's not always the pickup's fault. There are other components. In the case of what you and most of us are doing, is it's a simple volume and tone. It gets a little more complicated when you put in a switch. If you got a two pickup instrument, and 2 volumes and 2 tones, you're literally doubling your possibilities of something going wrong. And that same vein, a lot of people ask me, is a bridge ground necessary? Well, it always isn't necessary. Some yes, some no. Again, it depends upon how good your shielding effect is. If you're using a
That's
full.
interesting. So the bridge ground, aka the string ground,
Uh-huh.
isn't always necessary.
Not in certain guitars, because if your shielding and grounding is good enough, there's no way it's going to get to anywhere.
Because I have an arch top at home built by who somebody I won't say, because it's not to embarrass him here, but it's one of the best instruments I own. It's a wonderful guitar, and as a gigging guitar, it's never failed me. But every time I've ever tried to record with it in the studio, I have to make sure I get through the entire recording with an alligator clip from the output jack all the way around to behind the tailpiece, where the string leaves the tailpiece, so I can get a string ground at least, because there is a faint hum, and it's an archtop guitar. You're not going to shield the inside of that thing.
Well, what kind of pickup is it?
Uh,
Is it a humbucker or a single coil?
it's a humbucker.
Okay, and it got a metal cover on it?
No, it's one of yours.
Oh, okay. Well, no, it's shielded then. It's
Yeah.
shielded in. It's shielded internally.
It's
Okay.
shielded
Yeah.
in
But again, it depends upon how much. Again, it depends upon how much. Remember, we said about having too much exposed wire.
Yeah.
Again, it's the exposed wire problem. You need to probably have a quick look with a mirror and a. Is it
I've never looked at the electronics on that guitar.
Uh-huh. That could be something. I've had many people call me up saying that I've got full electronics in here and I've got no noise and the bridge is not grounded because they've got a good closed circuit for noise. See, the human body is if we were to take a Stratocaster, you and I, Doug, and we were to put it in between our bodies together, face to face, we face to face in between, put it in there, and both of us touching the strings, grounding out, there'd be no noise because our bodies would be acting as a giant shield.
Right.
We'd be you and I would be the Faraday box. You could do this with your wife if you want. I think it'd be a lot more fun than with me.
I was just trying to wonder what that Instagram picture would look like with you and me.
The new shielding for Stratocasters.
So back to the subject.
Hey, we could call it. Hang on. We could call it the proper sandwich.
So back to the subject of troubleshooting. When somebody presents a guitar, do you have a routine that you go through for troubleshooting a circuit? Is it always the same?
First of all, I listen to what the customer. The most important thing is you've got to listen to what the customer is telling you, because even over the phone, I can be a phone doctor, but experience tells me certain things like you got your jack socket wired backwards. It's a pretty simple thing, but generally I listen to what the customer is trying to tell me, and go from there. I have to know. People.
Well, I'm just asking that before we get to that, I think Andy Morris has a hand up. He has a question, I think. Do you have a question, Andy?
Yeah, it was. I was trying to get in, but it was related right the way back to like top values and the 1 meg thing, and then when you said about a broken wire, why is it that it seems to be like electrical circuits when you roll a volume down or you do anything like that, there's a break in the circuit? Why does it always seem to affect treble frequencies first? What is going on with the treble frequency over a bass frequency that we need to put like a treble bleed in? Like what? I've never understood what's going on there electronically, and it would be nice to know.
Andy, great question. Pots have their own built-in capacitance. And that capacitance, remember we were talking about capacitors, and because it's so small, it bleeds out the treble frequencies. And that's why you put a treble bypass to bring it back before it gets sucked away to ground. And that's because it's got a slight capacitance in the pot.
And
That's all it
is that because treble frequencies are less
They're easier to
higher
get rid of.
voltage? They're easier to get, right.
They're
Okay. So
easier to get rid of.
literally they're not
Yeah.
as powerful. So they're going to be the first ones to get rid of when you turn the volume down because of the
Right.
capacitance
Right.
in the pot.
Right. Right. Right.
Right.
Exactly.
There we go.
Okay.
Yeah.
There you go.
That also, for me, begs the question about treble bleed circuits. That little bridge between
Mhm.
the
It-
the input and the output of the pot.
Mhm.
We've been putting those in and cutting them out of guitars all our lives. Half of our customers who come with guitars that have them pre-put in there, they're asking us to take them out. The other half that don't have them are asking us to put them in. If I thought about it early enough in my career, I could have just saved the ones that I took out and put it in the other guitars. But
I was thinking the same thing.
I've personally seen them in all form and fashion, from just a single very high rated capacitor to a capacitor with a resistor.
Mm-hmm.
And is there and there doesn't seem to be any real uniform, at least in my experience, any uniform formula for what a treble bleed circuit should be. Is there one?
Can I just add in something very, very quickly onto that? Is as the formula, I've noticed that some of the treble bleed circuits, and I don't know which one, which is why I'm asking, is when you get to 0, not all of the volume is cut off. You're just left with treble frequencies coming through, but some of them actually do taper off at the same time. So that was which one of those does that?
Yeah, that's where the resistor comes in. The resist, and there really isn't a formula, because not all pickups are the same, not all pots are the same, because we don't have a uniformity. If you were dealing with something that was exactly a pickup that's exactly 10K, and you're dealing with a volume pot that's exactly 500K, because there's variation and there's plus and minus tolerances. That's why they have to use, it really does vary. It has to move with the components you're using.
So when you're trying to again serve a customer, where the complaint from the customer is every time I roll off my volume, I lose I lose all my highs. Obviously, one of the answers might be a treble bleed circuit.
Yeah,
How do you determine what it is you're going to use as the components for it? What is there?
Like a 1K resistor and a 0.01 capacitor works fine.
Okay. And that works fine, like one of those things where that'll work fine in all circumstances. I don't have to start messing around with.
Well, that's the problem. That is the problem. Does it cure the problem? Maybe you might need to increase the resistor to a 10K resistor. So I'm trying to say is you can't just stick a general number to it, because all the components vary so greatly.
Right. Okay.
When I tell you a pot.
Oh, go ahead. Sorry, I didn't mean to interrupt.
Oh, when something varies as much as a 20% plus or minus tolerance, you can imagine how a 1K resistor might have to be a 10K resistor. If you're dealing all the way from 400K to 600K, again, it's the balance. It's if we were dealing with military spec is plus or minus 1%.
Right.
But you pay through the nose for that. You really do pay for it. If you want military spec, yep, you can get military spec.
Is it? I mean,
it's not necessary. It is not necessary.
Using any of that on a Strat.
I mean, you pay like 5 times the price for a potentiometer just to have the military spec of 1%. You're better off buying 100 volume pots and just measuring them all one at a time, writing the value on the back of them, and hey presto, you're going to come to one that's 501 or 502 or 499.
Okay. One more question as it relates to treble bleeds. I had always heard it described, and I don't know whether it's true or not, it's just something I took for face value, that when you're putting a treble bleed circuit onto, say, a 500K pot, that effectively, electronically, you're converting it to about a 300K pot. Is that right or wrong?
Again, yes. Remember I was telling you about balancing. Okay, 1K resistor, 1K resistor. You put them together, make a bridge. They're in parallel. The electricity splits itself equally between here and between here. So it would be that's a 1-to-1 ratio. Now, if you have a 2-to-1 ratio, so there's 2, 1. Only 1/3 goes through the 2, and 2/3 go through the 1. So by you putting a resistor in the way, yes, you are altering the value of the potentiometer as to where the electricity goes. Yes, it's down to parallel resistance. Yes.
So I, like I said, I always understood that as the case, as it was described, but it always begged the question from me of saying, well, why wouldn't I then just put in a 300K pot for that?
Well, because
Again,
remember that whole problem of, will it all go to the amplifier? Will the signal all go to the amplifier?
right, okay.
Okay. The 1 meg pot, much better, because if you got a front end loading of 1K as compared to 1 million, there's the big difference. You can not, once you've turned that puppy all the way up, it's a 1 million ohm resistance in the way of ground. So that's good. But it's a balance. It's the balance. No, that's why I just use a capacitor. I used to use a 0.01 capacitor, even sometimes smaller, even sometimes a 0.0001 capacitor, just enough to bleed off, so it doesn't get. You're trying to counter the capacitance that you lose going to ground, because one leg of your volume pot is going to ground.
Right, okay, so you're trying to allow those highs to pass
Right.
output,
Absolutely.
as opposed to be attenuated by the pot.
Right.
But if without it, whatever the size of the pot would be attenuating it regardless without the pass.
That's what it is. You're giving those frequencies a different, less resistive path to go.
Okay, I get it. All right, so back to the diagnosis question, or the question about troubleshooting. Customer comes in and they hand you a guitar that's an electric guitar, and they say, something's wrong with my electronics. And you don't have the benefit of a more descriptive customer who's going to tell you, that whenever I'm standing in front of the window with my neighbor's garage light on, it seems that my Strat is a little bit too bright when I'm standing on my left foot. That, you have those customers that are descriptive to the nth degree about their electronic issues. You have the other customers that say, something's not right here, I need it fixed. Beyond the 20 questions with your customer, do you have a routine that when you're sitting down looking for where a problem might be in a cavity, because I always used to just start from the jack and work my way backwards through the circuit, but I don't know if that's necessarily the best way to do it.
No, first thing I do is I plug it into the amp and play it.
Okay.
I've tried to find out what the fault is first. Basically, if there's, say, it's a twin humbucker guitar, and one humbucker sounds great and the other one sounds pathetically weedy, I then fiddle with the knobs and pots and see what it is. And also at the same time, I then okay, now I know I got a problem. I built this.
Okay, what is that?
This is so I can plug it into guitar and plug my meter onto these two terminals, alligator clips.
Yeah, all right.
And I plug them onto my meter, and I can measure things and make sure things are looking good.
Well, okay, so you're plugging directly into the jack, so you can clip onto your meter. I don't know how to ask this question. If I've always been under the impression, if a signal, now I guess the question then is if a guitar, if you're looking at your meter And you're looking at the signal for your, presumably, I guess you're looking for the reading of your signal or your pickups.
Mm-hmm.
But if all of that is passing through an electronic circuit, you're not getting a true reading of your pickups. Is that correct?
Well, yeah, yes, you are measuring some of the pot, but here's an example for you. I actually had a customer come in and complained of, there was a discrepancy in the pickups quite greatly. So what I did was, it was much easier to drop out. It was a semi-acoustic, of course. I dropped out his, plugged it in. Sure enough, I could hear a problem. So now I need to know, was it the pickups or do I got a control problem? So I pulled out, got the three-way selector switch, and I changed over the two pickups on the actual selector switch, plugged it back in again, and sure enough, now the problem was on the other pickup.
It was on the opposite pickup. Okay.
And that told me I've got a control problem. I don't have a pickup problem. I've got a control problem. It was that simple. It was that simple. You sort of got to apply a lot. You got to apply a logic to it.
Right.
But that was the simplest way. And sure enough, I had to drop all his controls out of there on that one pickup. I knew which ones to get out. Had to drop them out and replace it. And it turned out to be the volume pot was the problem.
Okay. That's a good tip about the switch, about switching the two.
Yeah. Yeah. There are simple ways around it. And it's just think about things for a little while. I mean, sometimes if guys, if you've got a problem, call me.
Well, this is a public conversation that reminds me of all of those conversations we've had on the phone 30 some odd years ago when we first met. Of me calling and asking you dumb questions about electronics.
But it was the same. It was the same with the guy with the jack socket that was right backward. He spent 2 days wasted when he could have made a 2-second phone call, and I said, "You got your jack socket wired backwards." But sometimes it doesn't hurt to call and ask people things. Don't let your pride come in the way of making a phone call.
Oh, absolutely.
I mean, it's so much simpler. I've got 54 years of experience. I wouldn't ask you how to do bracing because I don't do bracing.
Right.
I just don't do it. But I mean, I actually had to go over to Bob Benedetto, his house when he was in Pennsylvania, and I actually had to teach him how to wire up a guitar. Oh God, this was like 40 years ago. I had to go to his house and teach him how to do it in Pennsylvania. And what I did, it made it simple. I actually wired up a harness and just left him the harness and said, "Here it is. Just copy this every time."
Well, I think to a degree that is the kind of the opening gambit for a lot of us in this business when I first started, swinging a fret hammer. Whenever there was an electronics problem, there's a monkey see, monkey do aspect to it. There's a and at one point, the colors of the wires were as important to me as almost anything else. So, because you were trying to copy what was going on, either in a diagram or if you had a guitar that you were going to replace the pickups on and replace all the pots on, you made a careful effort of making sure you traced where everything was going, so this way you could kind of put it all back the same way without even an appreciation at the time for me with what all of these different components were doing. And of course you learn from experience along the way, or in my case, I learned just by calling you. So I think there is a degree of that aspect to it for all of us, where we kind of hunt and peck our way through this until eventually it makes some sense to some degree.
Well, it's another example. Many years ago, when I went to the show out there in Woodstock, a customer of mine was having amazing, brand new guitar, solid body. I was able to access the control panel quite easily. He said, "I can't get my volume control to work. It just won't work. I don't know what's wrong." I said, "Well, we're going to be at the show. Bring it along. I have a look at it." And what had happened was he dropped a little piece of length of solder on the volume pot, and it had stuck between the ground and the sweeper.
Okay,
So it was literally shorting out the volume pot. It was not working
sure.
because, I mean, you know, I took these with me. I went like this, looked inside, said, "Oh, there it is." Got a pair of pliers, took it out. Hey, presto, it worked. It was something, he just missed it.
Yeah,
He just totally missed it.
sure.
I mean, sometimes it's the simplest, silliest little things. I mean, I had a problem once, this little tiny piece of wire, and I hadn't got one tiny little strand. I missed one tiny little strand. You can barely see the little, I was missing one little strand, was still touching the live. And the guitar was dead. That one little tiny strand I had missed on the jack socket was shorting the guitar out.
Right. Yeah. Yeah, it's certainly one of those aspects of work where conscientiousness and cleanliness counts. You know,
Yeah, makes a big difference,
you can't
especially when,
look right through that.
well, when you consider the wire I'm using to make pickups is as fine as a human hair.
Mm-hmm.
Just one little tiny piece of wire that thickness will completely kill a guitar.
By the way, that the Belden looking wire that you held up there,
Mm-hmm.
where are you getting because your wire has always been the best wire I've ever seen. In fact, many years ago, you sent me a bunch of it, and it was like, to me, it was like I couldn't find as good a shielded wire as you had. Where do you get your wire from?
I get it from my business partner in Korea. He sends me over a 500 meter length. So yeah, I've been using it for years.
Okay.
You know, it works. It's good. It's just, I mean, it's good stuff.
Yeah. Okay.
It's good stuff.
Yeah.
Any other questions? Anybody got any questions for me?
Anybody got
Yeah,
any questions out there?
Do you
I do.
use that grounded wire or that shielded wire to wire up an entire guitar, or just from the jack to the volume?
Oh no, the whole guitar. The whole guitar. Whole guitar.
Thank you.
Yeah. Yeah.
I
I
got
mean,
a
Oh, go ahead, Zoe.
back to the beginning of the conversation when we were talking about all of the signal, being able to let all the signal through from the amp.
mhm.
You're making it sound like that's really important. Like, you can even take off the tone knobs or whatever. I'm just basically curious, like why that would be so important since we've been doing it this way for so long. And I understand that if you have the 250K pots, it sounds like you're just losing a lot of the signal. But other than that, can you just talk more about what the issues are there?
Yeah, sure. I mean, it's just what I'm a proponent of, getting the maximum out of the instrument. That's what it's about. If you're, people have been going along now for 70 years, happy with what they've got. And then some people say, "Oh, I wish I had more power out of my guitar." Well, even an extra 3 or 4% can make a difference.
Well,
Okay.
you do see a lot of guitar players out there that have, whether it be like through a signature series guitar for a particular artist or custom wiring, where the people are using a push-pull pot to bypass all the electronics and go right to output. I think a number of guitars for, I forget who, but like people like Steve Vai and Joe Satriani and those kind of guitar players had their guitars wired up like that, where they can just use a push-pull pot to go directly to output. This way, none of their signal from their pickups is being attenuated at all. And I've always thought of that as a kind of an interesting option on a menu of services to have to offer to customers who would be the ones who would complain about saying, "Oh, that just doesn't seem like the pickups on this guitar have as much oomph as I'd like."
Mhm.
It may be just a matter of the fact that their electronics are attenuating too much of their signal,
And the amplifier's got too much of a front end loading. Mhm.
and being able to offer them just a push-pull pot to be able to have the experience of, what these pickups might actually sound like without that.
Without any coloring, without any external coloring. Yeah.
Yeah, and it's a whole lot less
Yeah.
expensive than buying
It's
it.
it's just, it's a simple thing to do.
Yeah.
It's a very simple thing to do. Same with same with wiring on Stratocasters. By putting a push-pull pot, and I usually put it on the back tone, by actually taking the bridge pickup, taking its live away from the 5-way and sending it straight to the volume, you actually now have 7 combinations on a Stratocaster. By
Run
a
up,
simple,
run up by me again. What did you know? You're doing what?
by taking the volume, by taking the live of the bridge pickup
Yeah.
and putting it to a push-pull pot. When it's in the normal down position, that signal goes to the 5-way selector as normal. But the moment you pull it up, it takes it to the volume, directly to the volume pot. So when you're in position 1 with neck and you pull it up, you now have neck and bridge on. Now you slide the 5-way selector into the number 2 position with bridge and neck, bridge and middle.
Right.
And you pull it up, you've got all 3 pickups on together. Those are the
So
2 combinations you're missing.
That's interesting. So you're doing that push-pull pot modification where the bridge pickup goes directly to the volume pot.
Yep. Yep.
For some reason, I've always done it where you pull up the pot and it reroutes the live to the first lug on the switch, so that it joins with the neck pickup there. Is that
Well, it depends upon which pickup you can do it with. You can either do it with the neck pickup rerouting or the bridge pickup. I've always just done the bridge pickup. But
right.
it's just reroute. It's literally taking it. You take the wire off where the live goes on. Tag 4 or 5, whatever what it is,
Right.
Of the bridge pickup. You just take it off, put it to the.
So you're
number,
rerouting it to the output of the switch.
No, rerouting to the output of the volume, so the volume still controls.
Oh, okay. So you're rerouting to the output of the volume. So
Yeah, you don't want to go to this. You don't want. Yeah, so you're taking it away from the switch, and not when you've got it turned up like that, and you don't have any dead positions. You definitely don't have any dead positions.
So let me ask you an electronics question then, because if you take the live pickup, the live wire from the bridge pickup, and you wire it directly to the output of the pod.
No, not the output, the input.
The input. Okay, all right.
Input of the pot.
I misheard you there. Okay.
The input of the pot.
Okay, so you still have volume control over it. It's just bridging to whatever else is joining the volume.
Exactly. It's exactly what it is. It's cool because you really, especially when you get the bridge and neck pickup on together, you get very much a Telecaster sound.
Right. Yeah, that's
very much.
It's a good mod. We've done it a number of times for lots of different customers.
Well, I don't know if I told you guys last time, but I do for a Telecaster, I do a Super 5-way that'll actually fit beautifully into a Telecaster cavity because that's quite a narrow little cavity. But what it gives you the 2 sounds that you really are important to have on a Telecaster. And Fender's just now doing it with their 4-way. They give you the 2 pickups together on in series, which is like putting 12 on the amplifier when you go to that. But my Super 5-way, I give you position 1 neck as normal, position 3 both on in parallel as normal, position 5 I give you bridge pickup on. But the 2 in between positions I give you, position 2 you get both pickups on together in series, which really fattens up the guitar. I mean, we're talking fat.
Right.
And then position 4, I give you the 2 pickups together in series, but 1 pickup is turned around out of phase.
Now, is this using one of those like
double wafer? Yeah, it's a double wafer switch. Yes. Double wafer. And I tell you that position 4 thing, when you have the 2 pickups together in series out of phase, it's the best honky tonk sound you've ever heard. I mean, really honky tonk. Because when you put 2, the old Pete Green thing where he had the 2 humbuckers. In his case, what I used to do was just flip 1 magnet over. He'd send me the guitar, and I'd just literally turn the magnet upside down, shove it back in, and when he was in the middle position, they were both out of phase.
Do you have a wiring diagram for that super switch thing for a Tele?
I do. I even sell those switches too. I have those switches in stock.
Oh, cool.
Yeah, and I have a wiring diagram. The only one thing you do have to do is the ground wire on the metal cover of the neck pickup. You have to snip that and put a separate ground onto the cover. So you have to run another green wire out from the neck pickup. That's all. Because that's the pickup I turn around out of phase. And if you do it with a metal cover on it, you can't do it with the bridge pickup. It's a little too complicated. So by you can do it, but you got to put a separate ground onto the metal cover of the neck pickup. That's the only got to do.
Okay.
But it's cool. It makes a Telecaster really useful.
Wow.
Far be it for me to cast nasturtiums.
Ed Bicker used to use the Telecaster really usefully, right?
Yeah,
He was the only.
a few people have used it kind of usefully, but they didn't use it as usefully as my wiring. Any other questions?
Do we have any other questions for Kent?
I'll ask one if that's okay.
Yeah.
Kent, I just wanted to pull you way back to the beginning. You mentioned solder for. So I'm going to say aluminum, just in honor of my American friends, even though it pains me to do so. Aluminum for soldering.
Aluminium.
That's what it is.
Well, I don't mind, Gary. I don't mind, but here's the reason: you guys spell it differently.
That's true. It actually is spelled aluminium. Yeah. Just
Gary, are you in England?
I'm in Ireland.
Oh, well, almost the same thing.
Ooh, be careful! You're on dangerous ground.
Yeah, but you could be in Northern Ireland.
Well, true, but I'm not.
Okay, listen. The wire I buy, this wire I get from England. The solder I get from England.
Okay.
Yeah.
Is there a brand or because I didn't know that was a thing, and the main reason I'm asking is because I've long considered using something like the aluminum flashing tape for shielding cavities and stuff because it's much cheaper than copper tape. But the difficulty in obviously soldering it for a nice contiguous path is made that less realistic.
Okay, Gary. Now, when you're doing that,
Jerry, by the way.
Jerry.
Oh, Jerry, I'm sorry.
That's okay.
You're so small I can hardly see you. The one thing when you're putting multiple sheets together, you don't have to solder the whole seam.
Sure, I know that. Yeah.
Okay, great. Because a lot of people seem to think, "Well, I got to solder the whole seam along there." It's like, no, you just have a bridge. Anyway, it's Loctite. Loctite. And if you happen to have a pen and paper, I'll give you that.
Sure, please. Thank you.
Okay. It's IDH 291345. And Loctite is now owned by Henkel.
Okay. And using that, is it straightforward? Do you need to do anything?
No, 30 watt soldering iron is fine. 30 watt soldering iron is fine. But it does spit.
Okay.
Okay, be careful. I mean, I say that. If you're doing something on a guitar, I usually, if I'm doing in the guitar, I put rags around. Because you don't want that hot stuff spitting onto the finish of the guitar. So, it does have a little bit of a spitability.
Okay, good tip. Thank you.
Really, really good. In fact, if my son is in England, he's in Ashford in Kent. And you can look him up under Armstrong Music over there. And he can help you. He can help you out with all this stuff. Whatever. If you got a problem, just contact my son Aaron.
Cool.
And he makes pickups and does rewinds and rebuilds there in the UK. I spent 28 years over there. So
I'm going to ask a question related to something you just said. When you're shielding a cavity, say with copper or in the case of Jerry asking about the aluminum, but when you're doing a copper shielding job, did you just say you don't have to solder the entire length of the seam?
Oh no! Just you just need to give it. You need to give the.
Now, of course, I'm hearing this 40 years too late, but so
you must spend a lot of time welding seams. What are you
I've
building, a
been
battleship?
upholstering the inside of guitar cavities for half my life here. So you don't have to run a bead of solder along the entire seam?
No, not at all.
Okay.
You just gotta give a bridge. And what you're doing is you're putting a bridge in so the electrical signal is picking up, has a way to get out to ground.
I think you just changed the rest of my natural life.
Oh, ye of little knowledge.
Oh my goodness.
That's why we have these little chats, you know.
Well, it looked good after it was done.
Oh yeah, look, wonderful. Whoa. Yeah.
All right.
Any other questions, guys, gals?
Anybody else?
We had a couple in the chat that I missed. Can I back up? Rhett Harris wanted to know, how do you measure the value and taper pattern of a pot with a multimeter if covered with solder or is not specified otherwise? Is there a way to suss
Yes,
that?
very simple. To measure the actual value of the 3 terminals, you just touch terminal 1 and terminal 3. You're measuring the track. That'll tell you that. Then if you actually take terminal 1 or 3, doesn't matter, and the middle terminal onto a digital meter with something like, this, alligator clips. I have lots of, spare alligator clips. I just clip them on the tag so I don't have to have my hands touching anything. And you very carefully, just with a digital meter, you just very carefully roll it up and down and watch the numbers go up and down very slowly, and just watch them go up and down, and it'll tell you whether you've got a linear or logarithmic.
Okay.
So let me ask you a clarification on that. You said more than once, you said make sure you're using a digital meter. So a meter with a needle wouldn't be advisable as to why?
It's a little harder. It's a little hard to be more accurate. I mean, in fact, I can't remember the last time I saw a swinging needle.
I've got one right over there.
Oh, I've got them. I haven't used them in 1,000 years. I've got them. But in fact, I carry one on my motorcycle just for emergencies to measure things. But it's a little hard to. You can see the needle going. You can actually watch the needle if it's a big enough one. Yeah.
Okay.
Yeah. I mean, it is doable. It is very doable. But you just measure slowly. Just watch the numbers go up, or watch the needle moving slowly as it goes up and down.
Just saying that,
if it's linear,
halfway.
If it's linear, just turn the pot roughly halfway. And
No.
the value should be
in
roughly
both cases,
half, right?
No. Yes. But that happens in both linear and logarithmic. At the halfway point, it should be halfway, say 250 and a 500. Okay, once you've measured it, it'll still be halfway. It's getting from 0 to the halfway point, and then from halfway point to max. It's a curve. It's really hard. It is kind of hard to do. It really is kind of hard to do.
So more the differences in the beginning of the taper.
Yes, you're going to see as you're turning it, almost nothing happens, and then it happens very quickly to the halfway point. And then the same reverse in the other ways. Whereas with linear, you're going to see a nice even climb of numbers as you go along. So
arguably speaking, when you're say at where 2 would be on a knob or on
say 2.5. Say 2.5.
2.5, you would be a quarter of the way up the pot.
Right, and you should see, if it's a linear pot, you would see it. Let's just for argument's sake say 600. It's better do the numbers. You should see at the 2.5 mark point, you should see 150K.
Okay.
You wouldn't see that.
That would be on a linear pot, not
on a linear cat. You'd only maybe see 100K.
Okay.
All right.
Hey, Kent, real quick, on a side note, you don't have a British motorcycle, do you?
I don't anymore. I did. I had lots of, when I was in England, I had lots of British motorcycles. Lots of them. I had a Norton 88, a Biza. I had 3 matchlesses. I had a golden rule with my British motorcycles. I never drove them further from my garage than I could push them home.
Very true. I asked because you said you carried a voltmeter with you.
Oh no, now I've got BMWs.
Ah,
Old
very nice.
BMWs.
Excellent.
My oldest
Thank you.
my oldest BMW is a 250 BMW from 1965.
It's an excellent little bike.
Hey, what great little bike. Great little bike. Great little. I used to have two.
Thank you.
Yeah. Okay. Anybody else?
I have a question. Yeah. We were talking about like these really hot humbuckers, the Invader is 13 or 14, and this guy on here put one in the other day that was registered like 24 on the resistance, but
That's normal.
it's not so much the resistance that of the pickup compared to the induction it creates, right?
Well, in fact, there's two factors you have to consider. When you're talking 24K, you're talking super distortion. But the induction is not really as critical as you think it is, because what makes a super distortion really a super distortion is the magnets. If you slide an Alnico magnet in it, it won't be much of it'll just be graunchy. It needs a lot of ceramic magnets. So the induction's not really too important. Induction is to do with a gauge of wire. In my case, I get a much better induction into my pickups because I'm using 44 gauge wire because my bobbins are bigger, and I get a much better induction because there's less resistivity per inch, if that makes sense. Whereas most people use 46 gauge wire, which is quite a bit smaller. So their inductions is much harder to obtain because that resistivity per inch is much higher. In other words, basically, it's trying to impede the induction.
Are you familiar with the Bixby pickups? Have you ever taken one of those apart?
Oh, sure. Oh, sure.
Didn't he use 42 gauge with the magnets on the outside of the coil or something?
Well, the simplest pickup ever out there made was the old lipstick pickups. The Alnico magnet, they put tape on the Alnico magnet, and they wound the coil right on the magnet.
Yeah, no bobbin.
No bobbin. And they taped it up and shoved it up the tube. Simple, quick, cheap, and whatever. Burns pickups were also made very similar that way too. I've rewound just about every pickup out there in the world. So there's many different ways to do it. And most people did simple things like that because it was inexpensive. The Burns pickups were wound as a round coil. And then they had string. And they would tie. There was lots of little tiny strings around this coil. And then they would tape it. And then they would squeeze it down to be a rectangle coil and put it over the magnets.
Wow.
Yeah. And they didn't hot wax it. That was even those things were so microphonic. You can always tell a bad pickup. I've had some Japanese pickups in here from back in the early days of the 50s and 60s that you could hold them up, plug them in the amplifier, and you could sing right into it. It was like a microphone. It was.
Did the Bixby pickups have the magnets on the outside of the coil though?
Some did, some didn't, but they always had a metal core. They had a metal core in them. You got to have a metal core. You got to have something to make the induction happen around the coil, in the coil. There are many pickups that have got the magnets on the outside, but they always have a center section of a metal core.
And then he had the full Faraday cage around it also.
Oh yeah. Just normal. Yeah, just normal.
Great stuff. Thank you.
Well, you're welcome. Anybody else?
Yeah, I have a quick question. I had a client a couple of years ago who I was building a Strat for. They started out with, I want single coil, straight up, regular Strat. And so I built the pick guard for it with the pickups and everything in it. And late in the process, they changed their mind and now wanted 2 humbuckers in the pick guard.
Wow.
And so we talked for a while and I ended up building the other one. And I decided I wanted to make a way that we could use either or. And so what I ended up with, talked to a few people, no one had good answers for me. I ended up using like radio control airplane little connectors so that I wired from one end in and then the other end in, and that was the plug. I just wanted to know if that was a good plan or if you had a better a better way of wiring that so that you could swap out the pick guards, plug and play.
Yep, plug and play. Yep, no problem. And what I usually do, your biggest problem is you need one like I usually use a stereo, little tiny mini little, like they're like 1/8 inch or something plugs. And the reason I have to use stereo is because when you're doing the plug and play, unless you're willing to reroute the ground of the bridge straight to the jack socket, because normally the ground comes up and attaches to the plate. So if you want to just use a mono, really tiny, RC jack, I just little tiny. I got a bunch of them in my drawer, but I then if I use the mono one, I take the ground from the bridge and I route it through the pocket into the jack socket. So you don't have to worry about the ground on the plate because they usually
I did the same thing. I did the exact same thing. I just was wondering what the best plug and play connection or did it matter at all?
No, you did well. I mean, it's not something that's going to be he's going to be doing it every 5 minutes.
No.
Where you need incredible longevity of the connectors. But no, if it's something he's doing like once a month or once a year or something, no, you did fine. You did really good.
Thanks.
Mm-hmm. Anybody else? No, he loves me.
When
I had one quick kind of clarification. So for inductance, you're engaging that inductance in your pickup to obtain what result?
A better flow of electricity.
Okay.
Better flow of electricity.
And EMF is kind of the precursor or the antecedent to inductance, and inductance is the proper environment of like the copper being big enough.
Right. I mean, EMF is electromotive force. That's what the initials stand for. This is what you tend to use mainly in generators and motors. You don't tend to use it in our industry. We don't tend to use EMF. It's not like my winder. If I hand stop my winder while it's at maximum speed, I'm going to create a huge electrical surge of the EMF. We don't tend to suffer with that at all. It's not even relevant. And does everybody know what inductance is? Probably not. Okay.
That's something that's lost on me.
I was going to ask if you could explain that in layperson's terms, because every time I read it, it really hurts my brain. I get it eventually, but I have to read it once a year to remind me.
Inductance comes from to induce. And what we're doing here is, in our case of the electromagnetics, what we're doing is we're breaking magnetic field. Energy, under the first law of general dynamics, energy cannot be created nor destroyed. When the universe was first, whether you believe in the Big Bang or whatever, when it was first generated, all the amount of energy was X. And that has never changed. All that energy is still there to this day. It's X. It's just in different forms. So hence you cannot create nor destroy. So when you break a magnetic field with a screwdriver, you're actually you're inducing an electrical current in the screwdriver. That energy has to go somewhere. And then it's actually turned, as you're doing it, it's turned into heat. I mean, you're heating a screwdriver by millions and millions and millions, billions of a degree. But that energy has to go somewhere. And that's called, so what you're doing is when you're breaking the electromagnetic force, you're inducing an electrical current in the coil. And hence they measure that by the means of inductance. And it's not something that's really relevant for what you guys are doing. It's not something you really even need to know. The resistivity is the most important thing of what you need to know. And of course, the magnetic structure and magnetic fields. Those are more important. But inductance, it means to induce. How easy is it to induce the current? That's as simple as it is.
Yeah, I have a feeling that we're going to have to invite you back for one of these to just to talk about what we kind of like the things we talked about today, but as it relates just to pickups.
Well, may I make a suggestion for a next topic?
Sure, yeah.
A Q&A section. Why don't you guys write down things so we can just have a Q&A session of all the problems you've ever had over the years or anything else. Just, have a little list, make a little, every time I do it here in the shop. When I have a problem, I write the problem down so I have a note of it.
Mm-hmm.
So you guys could do the same thing. You could just, over the next 6 months or whatever, write down your questions or problems or things that you've discovered. What do you need to know about it? But if we could have a really good Q&A session, I'd be happy to do that for you.
Yeah, that would be great. That would be fantastic.
Hey.
All right, do we have any more takers before we let go for us? Going once? Going twice? Kent, I cannot tell you how great it was to have you here today.
Goodbye.
Thank you. Thank you so much for joining us. If everybody can
happy to do it for you guys. Happy to do it.
Everybody can unmute and thank Kent for joining us today. That was
Thank you so much, Kent.
Thanks,
Kent.
Thank you.
Thanks.
Was stellar.
Guys,
Thanks, man.
Guys, just so you know, you can always look me up. If you've got a problem, don't hesitate to call me. Seriously. And you usually get me up to 10 o'clock at night.
Yeah, that's fantastic.
Thank you so much.
Okay, guys. Good to see you.
Thanks, Kent.
Bye-bye.
Did anybody find a link to the aluminum solder? Jerry, did you find a link to it?
I didn't look for a link yet. No, I put the code in the chat in case anybody's looking for it.
Well, if anybody